Hello, my name is Monica and this is Lab 2, Lines of Charge. The purpose of this lab was to create a computational model of two charged tapes based on Lab 1. The experiment procedure was the same, but a more sophisticated computational model was made. From this, we can compare the results from both labs. The magnitude charge of one tape found in this lab was approximately 3.55 raised to a power of -8 coulombs. Principles used in the lab include Newton's second law, which states that the net force is equal to a system's change in momentum over time, and the gravitational force, which is the product of an object's mass and acceleration due to gravity. In addition, Coulomb's law gives us the electric force between two charges, which can be attracted or repulsed. As seen in the diagram, like charges repulse while opposite charges attract. The formula is 1/4 pi epsilon 0, which is Coulomb's constant, multiplied by the particle charges over the distance r squared and the unit vector r hat. In addition, the superposition principle states that an object can be divided into segments and the individual electric fields can be summed to get the net electric field charge. For the lab experiment, two pieces of tape were pressed together, then quickly ripped apart. Based on observations, the charged tapes were attracted to neutral objects such as a hand, but moved away from each other. This showed that the two pieces of tape were positively charged and therefore experienced repulsion from like charges. Next, tape B was placed between two objects, creating a bridge. Tape A was then moved underneath, while tape B was observed to float, again showcasing repulsion. Some assumptions made for Lab 2 were ignoring air resistance, assuming that charges were identical and evenly distributed along the tapes, but this time the charges were not concentrated as a single point charge. In this scenario, the system was tape B while the surroundings were everything else. We are given the K constant and the acceleration due to gravity near Earth's surface. Furthermore, the mass of one piece of tape was 2 to the power of -4 kilograms, the length of tape B was 0.2 meters, and the recorded distance between tape A and tape B while repulsed was 0.046 meters. In Lab 1, the magnitude of the charge of one piece of tape was 2.132 raised to a power of -8 coulombs. The new charge found was 3.54872 raised to a power of -8 coulombs. To begin with, the electrical field was calculated, then the line of charge was created. Unlike Lab 1, the tape's charge is not concentrated at a single point, so the charge was divided into segments. Next, we have the scale factors for the electric field, electric force, and gravitational force. The following section illustrates the superposition principle. The segments of the electric field are summed to get the net electric field, and the same is done to get the net electric force. Finally, the net electric and gravitational force arrows were created. Potential errors in the experiment include accuracy in the distance measured between tape B and tape A, and assumptions made such as ignoring air resistance and assuming equal charges. The smaller model illustrates the output when using Q from Lab 1. The electric and the gravitational forces were not equal as seen. However, using the new magnitude of the tape's charge, 3.5487 raised to a power of -8 coulombs, which was found by estimating, the magnitude of the electric and gravitational force were both 1.962 raised to a power of -3 coulombs. Using the magnitude of a tape's charge from Lab 1, which treats the tape as a single point charge, results in the model below. As stated in the previous slide, using the Q value from Lab 1 results in unequal electric and gravitational force arrows, while using the new Q value from this lab results in equal force arrows. Both estimates differ because the code used in the labs were different. Lab 1 was an oversimplification of the experiment, while Lab 2 more closely replicated the real-life experiment. As a result, Lab 2's charge value is more accurate to the real value. Thank you for listening.